Okay, we're going to continue on Unit 2, Lesson 8, and here we're going to go to polymers. Polymers. So, what is a polymer? A polymer. We have here poly. Poly, that's mean many or a lot. So, polymers are like a necklace. A necklace. And in the necklace, what we have pearls. Necklace. A moment. Yeah, necklace. And with pearls. Okay, so this is a polymer with necklace with pearls. In the polymer, the pearls, we call them monomers. Monomers. So a polymer is made up of monomers. This is the idea. So a polymer is a set of monomers. Okay, so I'm going to write it here. A polymer is a set of monomers. So when the industry or the chemistry was enough advanced, and we know how to make polymers, that's why now we have plastic. We have a lot of things that come from plastic. They are polymers. So example of polymers, there are a lot. Nature gives us example of polymers. For example, cellulose. Cellulose is a polymer. Is a polymer. Is sugar that is used by plants, and it is polymer. And if we see which polymer it is made of polymers like this ones here. Glucose, and they are bound by oxygen. And we have another glucose like this one, and we have a glucose like this one here, like one here, and etc. This is polymers. I have glucose bound to another glucose by what? By the oxygen. Oxygen bounds different glucoses. Yeah, I'm going to put another one, another glucose like this one here, like this one here, and this one here, etc. And we have, and etc. in the other side. Okay. So the glucose here, it is the monomer. The one it is repeating itself. This one it is the monomer. And it is, for example, in this case, for the cellulose, it is glucose. A glucose. And the polymer, it is the cellulose. The sugar, it is a big molecule. The cellulose, it is a big sugar. Okay. So how we can do polymerization? What we call polymerization, it is creating a polymer. So polymerization reactions. Polymerization reaction. How we can synthesize or construct polymers. How we can construct plastic, for example. Yeah, by what? For example, we have two reactions that we can do. First, by addition. Take one monomer, add it to another one by addition. And recall that ethenes, alkene, can do additions. Alkene. Why? Because they have double bond. You remember? For example, I take CH, for example, an ethene, H, and I can add it to it another, for example, another ethene, the same. Okay, this one it is the ethene, and this one it is the ethane. And by adding them together with another ethane, if I want another one, see, this is what the industry are doing. They are doing additions, and with given the appropriate physical conditions and chemical conditions, what we will have that, for example, this double bonding will be broken, this double bonding will be broken, this double bonding will be broken, and they will link one to each other. For example, I'm going to leave it here, plus. So what we'll have here, I will have this C with these H's, but this one, it is broken. So now it will be bound into this carbon here. And this one also, it is broken. I will have the H, and it will bound to the third one now. I'm going to put it in another color, etc. And I have another ones here. So what I will have in the end, I will have a big polymer. So if I take many ethenes, and if I make them react, and if I am smart enough to give the conditions for the reaction to occur, I will have plastic. That's why plastic, for example, it is in 20th century that we get plastic, not before, because we had to be smarter enough to make these reactions happen. And this is what now we can do, because we know how to make them happen. That's why we have plastic. We have all sorts of plastics, So how we represent them? We represent them like that. For example, I have many of these ones, H, H, C, H, H, and what they will give me, we're going to put like that. That means there are others, and I will have C, I will have H, H, others. We put them H, 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 like this one. And it continues. Okay, here it continues. We're going to put it like that. Usually we put them like that. What does it mean, continuous, in chemistry? And here also it's continuous. But sometimes how we do them, and this is the way that we prefer, or we put them like that, many CC, H, 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 and by reacting we put them like that, C, H, H, H here, H here. We put like this one, and we put them on the brackets, and we put here N, like that, what we put. So we put a reaction here, and we put an N. What does it mean, an N? Multiple, N, multiple. That's what, 1,000 if you want. This is how we represent polymers. And this is the chain that changes. This is the change that repeats itself. For example, which chain it is repeating itself here? It is this ones. They are repeating itself. I get them here, and I will get them in the other, the same, they are here, etc., etc. So N symbolize many. Symbolize many. And this is the monomer. The monomer, it is the one that it is repeating itself. It is the monomer. It is the period, if you want. Good. Yeah. For example, also we can have lots of other polymers, and here we're going to get some examples. For example, a polypropylene. Poly, it is plastic. A polypropylene. This one, it is plastic. This polymer, containers, outdoors, where we found them, carpeting. You see, when we understood how to do polymers and how it is, which is done, it is done with this monomer. It is this monomer that repeats itself. It is like that, CH, CH3, this one, and this one that it is repeating itself. We put it like N here, and this is polypropylene. that we found in plastic, containers, outdoors, carpets. Another polymer, the polyisoprene. This one, it is made of what? Where we find it? Rubber products, such as balls, example, yeah, such as balls, and waterproof boots, So what is the monomer? It is this one. I'm going to put it in another color. I have C double bonding, and here I have CH2, CH3, CH2, H. Yeah. And the one that it repeating itself, it is this one. All that stuff is repeating itself. I forget one here. All that stuff is repeating itself. And this is what we put N. So this is the one that repeats itself. So if I want, I will put it again and again. Another example, PVC or polyvinyl chloride. What do we find it? Plastic, water pipes, fluorine. Good. So what is the monomer? It is this one, CH2, CH with a chlorine, and it is this one here that repeats itself. This is the monomer, and it will be repeated indefinitely. Not indefinitely, but many times. Yeah. Another example here, it is polystyrene. The polystyrene. What do you find it? Insulation. For example, insulating the electric wires. Hard plastic cases. For DVDs, for example, for cases for DVDs. So what is the monomer? I have CH2, I have CH, and I have a ring of benzene. And this is the one that it is repeating itself. This is the monomer. I put an N here. It is a monomer. Okay. This is about the addition reaction. We are speaking about how we are going to polymerize. We have the addition reaction. This is what we spoke about. But we have another kind of reaction. So this is, yeah, addition. Addition, alkene, addition. Now we are going to go to condensation, polymerization. We can do it by condensation, polymerization. Nature do this one, condensation. In the condensation, there is water that we have to take off. Polymerization. For example, the proteins. The proteins are made. Proteins are polymers of amino acids. Amino acids. So you have two amino acids. They will bound by condensation, and what it will give you? They will give you. So amino acid. What does it mean? Amino acids. That means that the molecule has the function of amino, and it has a function of acids. So what will be the function? So normally it will be like that. C, I will have the function of acid, OH. This one will be bound to another C. I will have H, and I will have a function of the amine in H2, and this one will be bound to anything, an R. So this is the group of the amine in H2H, and we have the group of the acid O and OH. So go back again to your the course that we did for the functions. You have to be able to recognize. That's why this one we call it amino acid, because it has a function of amine and amino, and it has a function of acid. So the R here, when you change the R, you change the kind of the amine, of the amino acid. So here we are going to take two examples. One example. For example, I have this amino acid, C bounding to the C. This is the function OH. And I have here in H2N, and I have here IH, plus another amine. Another amine, it will be H2N, carbon, the same. I'm going to put it the same, O and OH. This one I'm going to put here an H. Yeah, nothing forbid me to do it. And I have here an H. So what will happen? This amine and this OH will react, because they are the functions. This function amine and this function of acid will react, and what will happen? Always there was water that will be that will be ejected, that will be produced. So what will be here? This OH will go, but this H2O, it will not go altogether. It will only expels water. I'm going to take which one? This one here. Okay, I'm going to do it in another. Okay, I'm going to put it here. So this amino acid will stay H2N or NH2. It's the same. It's the same, H2N or NH2. Carbon. Here I have a hydrogen, a hydrogen, a hydrogen, a carbon, and this OH will go, because this is an amine. It's like, you remember that we did the amides. This OH will be expelled by this amine here. But this amine here, what we'll have, because I have in H2, so it will be H and H, and this one will be broken. So what I will have here, NH, I'm going to put the H here, and the carbon, H, H, C, O, OH. And here I had the OH here, that will be the ones that will be expelled. I have an OH and I have an H here. This one will go to form water. And what will happen? This ones will bound. This carbon will bound directly to the amine. So this bounding, we call it a peptide bounding. This one here, this carbon, when it bounds to the nitrogen, we call it a peptide bounding. A peptide bound. And this is how the water is expelled. It is produced. So where we found these reactions? Yeah, we found it in a lot. For example, to produce nylon. Okay, so condensation, produce, for example, nylon. that we found in a lot. We found it. Well, we found nylon products. Yeah, we found it, for example, in running shoes. We found it in strap, in toothbrushes, and etc. Toothbrushes, etc. Lots of products that contain nylon. Yeah, so this is about polymerization. For the polymerization, we did 2: addition and condensation. When it is condensation, there is water, producing of water. When it is addition, there is production of nothing. They are only, it is a synthesis reaction. And that's it. So I'm going to stop here.